Get ready for some state-altering kinetic energy. We're about to heat up the dance floor on this episode of PS 100. Imagine these people are a bunch of molecules. Right now, they're in their solid state. As you can see, these molecules are always moving, but before the party starts, that motion is pretty minimal. That's why solids hold their shape. When our molecules get moving, we can measure their average kinetic energy, which we call thermal energy or heat. Once the DJ gets the party started, his music starts heating up the dance floor, and our molecules start to spread out so they have room to move. At this point, it looks like these molecules have melted into their liquid state. They flow through the room much more than they did in their solid state, but they're still relatively close together and fill only part of the club. Of course, not all materials have the same melting point, so you might see some molecules stay stiff and solid. When the party gets really hot, the molecules move even faster and spread out as far as they can, filling the whole club to make room for all their kinetic energy. This is their gaseous state. This explains why gases are less dense than liquids, and liquids are less dense than solids. Oh, and there's one more type of energy we can observe in this model: chemical potential energy. This is the attraction between molecules that draw them together and make them react. And the more energy you've got on the dance floor, the more free those molecules are to move around and interact. But be careful, sometimes those reactions can get violent. That's it for this episode, but there's an after party in the description below.